two apex predators of the modern sky, the American F-35 Lightning II and the Russian Su-57 Felon.
Stealth is not just about painting a plane black, it is a geometry game. The F-35 is built with a continuous curvature design.
The Su-57, however, retains a more flattened, blended wing body configuration, evolved from the Su-27 flanker family.
The F-35 utilizes planform alignment, meaning leading and trailing edges are angled to scatter radar waves in specific narrow directions.
The Felon also uses planform alignment, but its larger airframe presents a bigger physical target compared to the compact Lightning II.
Primary stealth relies on deflecting radar energy. The F-35's chined nose and canted vertical stabilizers are optimized for this deflection.
The Su-57 manages frontal radar deflection well, but its wide engine tunnels can create radar traps known as cavity returns.
A critical stealth feature on the F-35 is the diverterless supersonic inlet, which removes the gap between the intake and fuselage. The Su-57 uses radar blockers inside its straight-through air ducts to shield the turbine blades from radar detection. Rear aspect stealth is a major differentiator. The F-35 uses serrated nozzle edges to scatter radar waves from behind.
Early production Su-57s feature round, exposed nozzles, which compromise stealth from the rear significantly compared to the F-35. The F-35's belly is smooth, housing weapons internally to maintain a clean aerodynamic and radar profile.
The Su-57 also carries weapons internally in tandem bays to reduce drag and radar signature.
Even the cockpit is stealthy. The F-35 canopy is coated with indium tin oxide to prevent radar waves from entering and reflecting off the pilot.
The Su-57 canopy has a similar coating but retains a metal framing bow, which can slightly increase radar visibility.
In terms of radar cross-section, the F-35 is often compared to the size of a metal golf ball. Public analysis suggests the Su-57 has a larger RCS, roughly 0.1 to 0.5 square meters, closer to a beach ball.
Stealth relies heavily on radar-absorbent material, or RAM. The F-35 uses a baked-in fiber mat that is durable and highly effective.
Russia has developed new ferromagnetic paints for the Su-57, designed to absorb radar waves, though its durability is debated.
The F-35 features a sapphire glass EOTS window, faceted to remain stealthy while housing advanced optical sensors.
The Su-57 carries a traditional round IRST ball. While powerful, its round shape breaks the stealth geometry of the nose section.
Infrared stealth is the second front. The F-35 buries its engine deep in the fuselage to mask the heat signature from ground sensors. The Su-57's widely spaced engines provide incredible maneuverability but create a larger and more distinct thermal footprint.
Every maintenance panel on the F-35 has sawtooth edges. This ensures that radar waves traveling along the skin surface are scattered. The Su-57 shows improvements over previous Russian jets, but some panel lines remain straight, creating potential radar reflectors. The F-35 is designed as a first-day-of-war fighter, capable of penetrating the densest enemy air defense networks unseen. The Su-57 is doctrinally different. It relies on detecting enemies first using powerful radar, rather than absolute invisibility. The canted vertical tails of the IVE are essential for side aspect stealth, reflecting radar.
The Su-57 also uses canted tails, but they are all moving control surfaces, which can momentarily compromise stealth during sharp turns.
Stealth is also electronic. The F-35's AN/APE-81 radar uses low probability of intercept technology to see without being seen.
Uniquely, the Su-57 features side-looking cheek radars, expanding its field of view, a feature the F-35 lacks.
The F-35's greatest stealth asset is sensor fusion. It shares data instantly, allowing one jet to remain silent while another targets.
Russia pairs the Su-57 with the Okhotnik drone, extending its sensor reach without exposing the manned fighter.
The opening weapons bays momentarily ruins stealth. The F-35's doors open and fire extremely fast to minimize this detection window. The Su-57 features unique side bays for dogfighting missiles, allowing it to deploy weapons without opening the massive main bays. The F-35C variant brings stealth to the ocean, featuring larger wings but maintaining the same low observable characteristics. The Su-57 is designed for rough field operations, with rugged landing gear, but this ruggedness can add radar reflective clutter.
Aerodynamically, The F-35 sacrifices some speed and agility for maximum stealth shaping, prioritizing invisibility over dogfighting.
The Su-57 is a kinematic beast. Its shape prioritizes supermaneuverability and speed, accepting a higher stealth penalty.
Halfway through our analysis, the distinction is clear. The F-35 is a stealth sniper, the Su-57 is a stealth brawler. But let's look closer at their electronic skin.
The F-35's Barracuda electronic warfare suite doesn't just jam radar, it can identify and geolocate threats passively.
The Su-57 uses the Himalaya electronic countermeasures system, distributed across the airframe to break enemy weapon locks. The F-35 pilot sees through the plane. The distributed aperture system projects a 360-degree view directly to the helmet.
The Su-57 cockpit is modern, with large MFDs, but it lacks the spherical visual integration of the F-35's helmet system.
These sensors detect thermal launches from miles away, allowing the F-35 to remain silent while tracking ballistic missiles. While maneuvering, the Su-57 exposes its large planeform to ground radar, momentarily increasing its detection range.
The F-35 is optimized for stability and consistent stealth angles, preferring to kill from long range rather than turn and burn. Manufacturing tolerances on the F-35 are measured in microns. A single mismatched panel can compromise the aircraft's stealth rating. Su-57 production has improved, but observers note inconsistencies in surface finish compared to Western 5th-gen standards. The F-35 nozzle design mixes cool air with hot exhaust, significantly lowering the range at which heat-seeking missiles can lock on. The Su-57's engines run hotter and lack the extensive thermal shielding of the F-35, making it more vulnerable to infrared sensors.
When stealth is not required, the F-35 enters beast mode, carrying external weapons but sacrificing its invisibility.
Similarly, the Su-57 can carry heavy external payloads, operating as a 4.5 generation fighter when air superiority is established.
The Su-57 features L-band radars in its wings, theoretically capable of detecting the approximate.
However, L-band radar lacks the precision to guide a missile. It tells the Su-57 something is there, but not exactly where to shoot. This creates a deadly game. The F-35 can fire from beyond visual range before the Su-57 can achieve a weapons-grade lock.
If an F-35 fires, the Su-57 relies on its extreme agility and jamming to defeat the incoming missile kinetically. In peacetime, the F-35 flies with Lüneburg lenses, reflectors that intentionally make it visible to radar.
The Su-57 also uses reflectors during testing and transport to prevent rivals from recording its true radar cross-section data. Strategic stealth involves range. The F-35 relies on tankers to extend its reach, a vulnerable moment in its mission profile.
The Su-57 carries a massive internal fuel load, allowing it to operate deep behind enemy lines without immediate refueling.
The F-35B's STOVL capability requires a lift fan, which adds weight and complexity but allows stealth operations from makeshift bases.
The Su-57 is built for dispersal. Its robust intake screens prevent foreign object damage on less than perfect runways.
Even gear doors tell a story. The F-35's serrated doors maintain stealth even when cycling. The Su-57's are more traditional.
Weather affects stealth. Rain can alter the conductive properties of the RAM coating, though the F-35 is all-weather certified.
The rugged Russian design is historically tolerant of harsh weather, but the impact of rain on its specific stealth coatings is less publicized.
To a legacy radar, the F-35 appears as nothing more than background noise or a bird, delaying reaction time until it's too late.
The Su-57 reduces detection range significantly compared to a Su-27, but it does not.
High stealth costs money. The F-35's maintenance of its stealth coating is notoriously expensive and time-consuming.
The Su-57 aims for a balance, offering 80% of the stealth capability for a supposedly lower logistical burden and cost.
Future upgrades for the F-35 may include directed energy weapons, requiring even better thermal management to maintain stealth.
The Su-57 is being adapted to carry hypersonic missiles, a capability that prioritizes offensive speed over passive stealth.
U.S. doctrine uses the F-35 as a quarterback, using its stealth to gather data for non-stealthy aircraft behind the lines.
Russian doctrine uses the Su-57 as a hunter-killer, designed to penetrate and eliminate high-value assets like tankers and AWACS. Every protrusion counts. The F-35 uses flush air data sensing systems instead of traditional pitot tubes to reduce radar return. The Su-57 retains a traditional pitot tube boom on the nose, a small but significant reflector that betrays its location. The F-35 is a triumph of stealth compromise, sacrificing raw kinematic performance for the lowest possible observable signature. The Su-57 is a compromise in the other direction, sacrificing absolute stealth for aerodynamic superiority and payload. One is a ghost, designed to never be seen. The other is a warrior designed to survive if it is seen.
In the end, the winner depends on the mission. Total invisibility or high-speed aggression.